Okay, so to finish up parametrics, we need to talk about arc length. So arc length in the last unit, in when we were just dealing with functions, was the integral from endpoint to endpoint of square root of 1 plus the derivative squared. So it still is, even for parametric, except we can rewrite it a little bit. So if I were to get a common denominator here of dx dt squared, then that would give me this. And if I were to simplify that, then this dx would also be dx dt. If I were to simplify that, then we could do the square root of the squared on bottom, and that's just dx dt, which cancels out over here. And then we're left with the square root of dx dt squared plus dy dt squared. So it's not a huge difference from when we were dealing with functions. Instead of square root of 1 plus dy dx squared, now it's dx dt squared plus dy dt squared. We have two different functions here, one for the x and one for the y. We have two different derivatives, square each of them, add them, square root, blah, blah, blah. Okay, so on these are pretty straightforward, I think. I need to do dx, so that's going to be 1 minus 2t. I need to do dy. 3 halves times 2 is just 3. Subtract 1 from the exponent. So there are the two derivatives. Sorry, it switched screens again. There are the two derivatives. If I squared this one, that would mean FOIL it out. So that would mean 1 minus 2t times itself. So I'm going to get 1 minus 4t plus 4t squared. And then when I square this, I'm going to get plus 9 t. So when I combine like terms, I get 4t squared plus 5t plus 1, all under the square root sign. So can I do the antiderivative of that? No, I don't think I can. I don't think that that's a perfect square. If I factored it, that would be 2t. If I factored it like this to try to make it a perfect square, that would be, no. So that would be 4t squared plus 4t plus 1. That I could factor into, if it were 4t in the middle, I could rewrite that as a perfect square using factoring, but it doesn't work, so never mind all that. That's not something that I can do the antiderivative of because of the square root sign. So grab the calculator, type in the integral, and there's your arc length. On this one, same thing. Derivative of x is, derivative of natural log t is 1 over t. Derivative of e to the t power is e to the t power, because the derivative of 1t is just 1. Square each one. And then I used the calculator on this one also and got 12.507. So when do you know when to use the calculator and when not to? In general, if it doesn't say don't use the calculator, then use it, because it's going to save you time and work trying to do the antiderivative. Some of these are going to be no calculator problems though. So like this one, for example, as big a mess as that is, that could be a no calculator problem, at least down to the end. So on this one, well, we did that one in class today. Let's look at this one. So we've got a point, a particle, a bicycle. This would be a silly bicycle course, but you know, whatever. It starts at 0, 0, and then as time goes on, it makes a spiral bigger, bigger, and then it goes back to the starting point. So you end up with something that looks kind of like a seashell, I think. So what is the total distance that the biker rides? Well, it starts when time equals 0. And when does it get to the point 6, 0? So if x is equal to 6 and y is equal to 0, then that would be when t is equal to 6 pi. So I use the point, use the x and y. So when is 6 equal to t over pi, and when is 0, the y coordinate at this point, equal to t over pi sine t. So there you go, 6 pi. So I need the integral from 0 to 6 pi of the derivative of the x. So this is a product rule. So your first function is t over pi, and your second one is cosine. So here's your first. The derivative of cosine is negative sine, plus here's your second times the derivative of the first. So product rule, first times the derivative of the second, plus second times derivative of the first. So there's dx dt. Derivative of y, product rule again, first times the derivative of sine, plus sine times the derivative of t over pi. So I've got my derivative here, my derivative here, square each of them, do the integral from 0 to 6 pi of the square root of the whole thing. I did not square that out. I did not simplify that at all. I just typed this whole integral into the calculator. Probably the hardest part of this problem was typing that in. And it gave me 57.206. This is a free response question that would be really easy to miss though, because the person also went from the end back to the starting point. So that's where the plus 6 came from, because this tells me the distance around the spiral, and this tells me the distance back from 6 to 0. So a total distance of 63.206 miles, because it said it was measured in miles. That's how arc length works. So when you're looking at the homework, find the first derivative and the second derivative, and then evaluate at the given point. So I think most of these are pretty straightforward. I'm looking for one that would be kind of tricky. This one might have some algebra in it you have to be careful with. Derivative of t plus 2 to the 1/2. Derivative of the outside would be the 1/2 and then the negative 1/2. And then the derivative of the inside in this case was just 1. So you could forget that that's a chain rule and still get it right. And then derivative of x. So the algebra on that one would be 1 over 2 times t plus 2, square root of t plus 2. Divided by 1 over 2 square root of t. And then when you multiply by the reciprocal, the 2's cancel out, and I just made it all one big square root instead of a square root on each one. So there was some algebra to be done there. On this one, dy over dx simplified a whole lot. So it ended up just being negative cotangent was the first derivative. And then the second derivative is derivative of negative cotangent over the original dx. And then when you simplify that, that's where this came from. Plugging in 3 pi over 4, the sine of 3 pi over 4 is root 2 over 2. The cosine is negative root 2 over 2. So you may have simplified this differently than I did, and that is completely okay. I highlighted the wrong one. You may have simplified this a little bit differently, and it's okay. So I ended up with negative 8 over 3 root 2 for the second derivative. If you had something different, you didn't simplify it the same way, not a big deal. So this one, write the equation of the tangent line. So on this, one thing to notice is they gave you the x and the y. So when I'm writing my equation, y minus the y coordinate and x minus the x coordinate, I didn't have to do any work there. They gave me the point. The only thing I really had to find was the slope. So I had to find the derivative of the y over the derivative of the x, and then divided by cosecant squared. Cosecant is 1 over sine, so that was divided by sine squared, which keep, change, flip. When you do the algebra, you should be able to end up with that. And then so there's your derivative. The part that I didn't talk about yet is, I know the point is 2, 1, but what time? At what time did that happen? So when is this x equation going to equal 2? And when is this y equation going to equal 1? So when I set the x equation equal to 2 and solve it, I get cotangent of t is equal to 1. Tangent and cotangent are positive in quadrants 1 and 3, and they equal 1 for the 45s. So pi over 4 and 5 pi over 4. When I solve the y equation, divide by 2, take the square root. So when is the y coordinate plus or minus 1 over square root of 2, which is also the same as plus or minus square root of 2 over 2. So the plus or minus includes all the multiples of 45. So that would be at pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, on and on and on. So what do those two have in common? Pi over 4 and 5 pi over 4. This one shows the point where that happened first. So I did pi over 4 for my point. And when you get the derivative here, and you find sine and cosine of 5 pi over 4, it simplifies a whole lot. And you end up with a slope of just negative 1/2. So that's an equation in point slope form that would be completely acceptable. That one wasn't real hard to solve for y, so I did a couple different versions in the answer key. But that was on the graph, when they give you the point, that kind of makes it easier. So when are the tangent lines vertical and horizontal? So dy dx again. So vertical is when it's undefined, so you have 0 on bottom. So I'm not going to go through all these. Vertical is when the bottom is equal to 0, so that's when dx is 0. Horizontal is when the top is 0, so that's when dy is equal to 0. So you can see the work that I did on each one of these. The horizontal one, I only cared about the top. The vertical one, I only cared about the bottom. When the denominator is 1, 1 is never going to equal 0, so that wouldn't have any points where the tangent line would be vertical. Be careful on problems like this one, because this is a chain rule, and we haven't done that in a long, long time. So derivative of the outside function is sine, and the inside function is 2t. So when you do the derivative of the outside, leave the inside alone, times the derivative of the inside, that's not something that you guys had trouble with. It's just something we haven't done in, 4 months? So something that you might have forgotten about. Derivative of the outside, leave the inside alone, times the derivative of the inside. That's where this came from. Looking for anything else that we might need to talk about. The concavity. When is it concave up and concave down? So I think this is the one I gave you guys for homework. So concave up and concave down depends on the second derivative. So I did the first derivative, dy over dx, and simplified it. And then I did the derivative of dy dx over the original dx and then simplified it. So that became negative 2 over cosine cubed. So concavity changes when the second derivative is either 0 or undefined. This is never going to equal 0 because negative 2 can't equal 0. But it is undefined wherever cosine cubed is 0. So that would be where cosine is 0. And on the unit circle, the x-coordinate is 0 at pi over 2 and 3 pi over 2. So that's where I got my numbers on my number line. So they gave us the interval 0 to 2 pi. So I've got 0, I've got 2 pi, and I've got my two possible points of inflection. So then you just need to plug in numbers from each section. So plug in something between 0 and pi over 2, like pi over 4, or pi over 6, or like 30, 45, or 60 degrees. So if I were to plug in, I don't know, pi over 3, then that would be negative 2 over, let's see, x coordinate for pi over 3 is a half cubed. I don't care what that works out to. It's going to work out to negative 16. I don't care about the 16. I care that it's negative. I'm going to have a negative divided by a positive. So in that interval, the second derivative is negative, which means that the function is concave down. Plug in something between pi over 2 and 3 pi over 2, like maybe pi. Then I would have negative 2 over, see, the x-coordinate for pi is negative 1. So when you cube a negative, you get a negative. So that's going to be negative over negative. That's going to be positive. So the interval from pi over 2 to 3 pi over 2, the function is concave up. And then plug in something between 3 pi over 2 and 2 pi. That's in quadrant 4. So x is going to be, whoa, didn't mean to do that. That's in quadrant 4, so x is going to be positive. So we're going to have a negative over a positive. That's going to be negative again. So there are your intervals for the different concavities. On these, we went over 18 in class today. Something that would be a little bit more reasonable, because that one had just a ton of algebra in it, would be something like this one that I didn't give you guys for homework. But this one is a little bit, I don't know, a little bit less tedious. Derivative of x would be, let's see, derivative of the outside, leave the inside alone, times the derivative of the inside. And then, I may need to look at this one again, actually. So do the derivative of each one and then square it. Do the derivative of the x, square it, the derivative of the y, square it. Do the integral on that interval. And then this one worked out to that. So that was a whole lot less algebra. The antiderivative was a whole lot less work. This one's not too terribly bad. This one was one that was the calculator. You guys should be able to write the equation, but you also should be able to get it that far without using the calculator. Because I wouldn't be surprised to see a multiple choice question where they ask which of the following could be used to find the length of the arc on the interval negative 1 to 1, and they're not going to make it as simple as giving you the one with the derivative squared. They're going to work them out. So 19, it said use the calculator. 20, it also said use the calculator. 21, this one, I mean, it just looks like a whole lot of simplifying stuff. One thing to remind you about here is you can actually simplify that. So square root of 4 is just 2, but that really means e to the negative 2t to the 1/2. It's inside the square root. Well, half of 2 is 1, so those kind of cancel out and just leaves you with e to the negative t. So that's not a calculus thing. That's just a, hey, remember how algebra works with exponents and roots thing. That could actually be simplified. And then If that's like e to the u, where u is negative t, then du would be negative 1. So I'm going to take that 2 and move it out here out of the way. I need a negative 1, so I'll put some negatives in there to balance it out. And then the integral of e to the u du, what's the antiderivative of e to the u? Well, it's just itself. So that's where this came from, setting it up for u substitution. And then this is the antiderivative. Plug in 2, plug in 0, and subtract. And that was the final answer that would be expected if this was a no calculator problem. So something like that is not unreasonable for a Calculus BC question. And, oh yeah, these. Find the length that the ball traveled. So it actually said find the difference between. So when did the ball hit the ground? Well, it hit the ground when its y-coordinate was 0. So when is the y-coordinate equal to 0? If you set the y equation equal to 0 and then solve it. So sine of 30 is 1/2. And so that's where the 1/2 came from. Divided by 80t, so that's why it's on bottom. And then simplify and solve, and you get t equals, you get t over 5 equals 1/2, and then multiply by 2, so you get, or multiply by 5, so you get t equals 2.5. So when t equals 2.5, what's the x-coordinate? Well, cosine of 30 is √3 over 2. And when you work all that out, you get 100 √3. So it started at 0, 0, goes through the air, and 100 √3 seconds later, it's back on the ground. So what's its horizontal distance? How far apart are those 2 points horizontally? 100 √3. Okay, how far did it travel along the arc? So that's the integral from 0 to when you set, how long did it stay in the air? So if you set 100 √3 equal to this and solve for t, you find out that it stayed in the air for 2.0 from right here. Sorry, lost it. So we have the integral from 0 to 2.5 because the time was 2.5 seconds. So the integral from 0 to 2.5 of dx squared plus dy squared. So the dx and dy. Cosine of 30 is square root of 3 over 2. So if you multiply 80 times square root of 3 over 2, that's where I got 40 square root of 3 times t. This function, sine of 30 is 1/2. Half of 80 is 40. So that's 40t minus 16t squared. So I rewrote those to simplify them a little bit. So here's the derivative squared, here's the derivative squared. Square those. And that wasn't something that I could do the antiderivative of. So grab the calculator. I typed this into the calculator and got 182.396. So it traveled 182.396 feet along the curved path. It traveled 100 square root of 3 feet horizontally. So the arc was 9.191 feet longer than the horizontal distance was. On these look like a mess, and they are a little bit, but it's mostly algebra and not calculus. Where is this horizontal and where is it vertical? Well, it's horizontal Let me see which one is which. It's horizontal where the slope is 0, so it's horizontal where dy dt is equal to 0. That becomes an algebra equation that's not too terrible. So there are the points where the top is equal to 0, so it's horizontal. It's vertical where the bottom is equal to 0, so there's the derivative. It simplifies some more, set it equal to 0. When do fractions equal 0? So fractions equal 0 where the top is 0. And then solve for t. So there is the point, there's only one, where the slope of the tangent line was undefined, where it was vertical. Approximate the length of the arc. So this goes from, it says t is greater than or equal to 0. So this is just one thing that goes on forever. It looks like it stops, and it does, but it goes on forever. I use the calculator on this one. So there's dx squared, there's dy squared. I did some algebra, and I didn't feel like it was going anywhere. It looked like it was just getting messier and messier. So I don't think I gave you guys this one for homework, but I typed it in the calculator, and I did the integral from 0 to like 10,000 or something, and typed that in and got an estimate. That is not something that you would be able to do by hand. So that is the end of the homework. The ones on here that I think are reasonable, this one's a lot of algebra to solve, but it wasn't too terrible. It looked worse than it was. This kind of question, you need to be able to understand this kind of question and find what they're asking you. Of these, this one with the calculator, you guys should be okay with. This one without the calculator, I think is reasonable. Finding the points of concavity, those are really good questions, because especially for multiple choice or as one of the parts of a free response. So they could ask you to do other things in part A and B and then make this a part C. And then the horizontal and vertical, I don't think any of those were too terrible. The slope of the tangent line, write the equation of the tangent line, especially when they give you the point. So all you have to do is the derivative and find the slope and then write the equation. Not too bad. Some of these were just a lot of work. Like this one was a lot of simplifying, but there aren't any of those that I think are so terrible that I would say, yeah, you guys probably don't need to know that. There wasn't really much in this assignment that was too far outside the realm of possibility for test questions, on the AP exam anyway. Maybe not for a classroom quiz where I'm going to give you 20 minutes to finish it, but on the AP exam, pretty much all of this one was fair game. So, hope this helped. Let me know if you guys have any other questions.